Okay, for this video, I'll be going through pure physics, kinetic model of metal. Okay, success criteria A, compare the physical properties of solid, liquid, and gases. So these are actually three states in our physics syllabus. So the kinetic particle model of metal states that metal is actually made up of tiny particles that are in continuous motion. That means they are continuously moving. So firstly, we look at the particle. Now, each sphere or each circle here represents a particle. Now, the particles have positive and negative electric charges that may not be uniformly distributed. So this allows them to exert forces on one another. I think you have learned something like this in your chemistry as well. Next, we go into the forces. The forces between the particles are represented by spring. Of course, this is just a model. Now, due to the spring, there are attractive forces pulling the particles together. Okay, and then next we go to the energy of particles in a solid. Okay, as energy is transferred to them, the particles will vibrate more vigorously. Now, the sum of the kinetic and potential energy stores of the model is called the internal energy. Okay, so we have been talking about internal energy store of the surroundings, internal energy store of an object. So this is what they are referring to. Okay, so we continue with the model's explanation. When the structure is shaken, energy will be transferred to the kinetic store of the structure. Now, the shaking will cause all the particles to vibrate. So in the process, some particles will get closer or further than their equilibrium separation. Okay, before we shake up this model. Now, the spring connecting the particles become compressed, okay, becomes closer together or extended, okay, which then increases the energy in the elastic potential store. So therefore, when the energy is transferred to the structure, the energy in the kinetic and elastic potential stores increase. So when energy is transferred to a real substance, the particles will also vibrate more. So we draw from the analogy in this model. Hence, the particles will push each other further apart and the metal will expand. So now we are talking about this real substance. Now, as the attractive forces get weaker with increased separation, when energy is continuously transferred to the metal, more and more particles will break away from their positions to roam freely. So the transition from the orderly arrangement of particles to freely roaming particles corresponds to a change from the solid to the liquid state. Okay, so you notice that in the solid state, the particles are close together, okay, and they are in their fixed position. However, in the liquid state, they are slightly further apart, okay, and they are in random positions. Okay, so that is why solids have fixed shape and volume. They have high density because within a certain volume, they have a great number of particles. Okay, and they are also incompressible because the spaces between them are very little, so it is not compressible. So if we compare to liquids, they have fixed volume but no fixed shape. Okay, they have high density as well. Okay, but of course the density won't be as high as the solid, and they are also incompressible relatively. So for the gases, they don't have any fixed shape or volume. Okay, they are low density and they are compressible. Okay, success criteria B, use the kinetic particle model to describe the different states of metal, solid, liquid, and gases, relating their physical properties to the arrangement, how the particles are arranged, and the motion of the particles, the movement of the particles. So these are two different things. How are they arranged and how they move? Okay, and also the forces and distances between particles. Okay, so we start with solid. So the particle arrangement, they are closely packed together, usually in a regular pattern and occupying minimum space. So that's why they have high density. Okay, so large number of particles per unit volume. So this is good phrase to remember. Number of particles per unit volume is high, so it has the highest density. So this is about the arrangement. But for the movement, okay, the particles vibrate about fixed position and held in position by very strong attractive forces, and this accounts for their fixed shape and volume. Okay, Next, we go to the particle arrangement for liquid. They are irregularly arranged with the particles slightly further apart than in solid. So if the question do ask you for the arrangement and they ask you to compare between solid and liquid, please use words that means that can compare, like further, okay, further or nearer, things like that. You can't just say they are far apart. So far apart, there is no sense of comparison. Okay. Then they have slightly smaller number of particles per unit volume compared to solid, so you are using smaller number to compare. So they have relatively high density, but not as high as the solid. Now we go to the movement. The particles are free to slide over each other throughout the liquid without fixed position. Okay, so the vibrate about fixed position is only reserved for solid. Okay, when you're talking about solid particles. Okay, for liquids, they are free to slide over each other throughout the liquid without the fixed position. There are also attractive forces between the particles, but they are weaker. So again, we do a comparison between the solid, so it is weaker. And therefore, this gives liquids a fixed volume, but they will take the shape of the container. Okay, whereas for solid, they are fixed shape. Okay, lastly, we compare the arrangement of gas particles. They are irregularly arranged and very far apart from one another. So very far apart. They have the smallest number of particles per unit volume, hence they have the lowest density. And particles in gases have the most energy among the three states. Okay, so we take note of this. Later I'll elaborate more. How about for the movement? Particles have very weak forces of attraction between them and move about freely in any direction. Okay, you can't use this slide over one another. That one is reserved for liquid particles. So the particles will occupy any available space, right? You heard of the term diffusion, right? They'll go from high concentration to low concentration. Therefore, this results in gases not having a fixed volume. So gases have no fixed volume and no fixed shape, and they are highly compressible. Okay, so these are the terms that you need to use when they're asking for comparison or when they're asking you to describe the particle arrangement and the particle movement in solid, liquid, or gas. Okay, so this is a diagram. So the solids, we start with solid, they are close together. Okay, for gases, they are far apart. Right, so the distance between particles increase from solid to gas. However, the forces of attraction goes from weak to strong in solid. Okay, now I'd like to talk about this point here, that gases, particles in gases have the most energy among the three states of metal. Okay, so we have for the particles, right, they actually have this Ke, which is the kinetic energy. Okay, because if we are talking about particles, right, we don't need to talk about the store. Stores is for the object. Okay, but when we are talking about particle, we can straight away refer to them having energy, because the collective sum of their energy will make up the energy store of the object, right? Because the object contains many particles, and individual particles have energy, and if we sum up all their energy, their kinetic energy, it will be the energy in the kinetic store of the object. Okay, so over here, particles, they actually have kinetic energy, and they also have potential energy, PE, potential energy. Now this potential energy does not mean like the chemical potential energy or the gravitational potential energy or the elastic potential energy. It's just potential energy that they possess. Okay, so kinetic energy depends on temperature. Okay, so as temperature increase, kinetic energy of particles will increase. So how do we see that? The particles actually vibrate faster, or they move faster, right? So temperature will affect the kinetic energy of the particle. How about the potential energy? It relies on the state of the object. Okay, but before I continue, we can maybe compare solid liquid and gas, which one has the largest Ke? Okay, which one has particles that are moving the fastest? So the answer is gas have the maximum Ke. Okay, because gas is actually at a higher temperature than liquid. Okay, and liquid have higher temperature than solid, right? Because they have melting point and boiling point. So gas particles actually have maximum Ke. That means solid have the least Ke. Okay, so this is for the Ke. How about for Pe? So take note, for gas, they actually have the maximum Pe because the particles are furthest apart. Okay, so I know previously we talked about the forces between the particles. So although gas have the weakest force of attraction between particles, right? But the Pe actually depends on how far the particles are far apart. Okay, so in that means solid has the least Pe as well. That means solid has actually the lowest internal energy. If I'm comparing the same substance but in solid, liquid, gaseous state, solid will have the lowest internal energy, whereas gas will have the highest internal energy, because internal energy is the sum of Ke and Pe, Ke plus Pe. Okay, so gas will have the maximum Ke due to it being at the highest temperature, and it has the maximum potential energy due to particles being the furthest apart. Okay, so you might want to take note of this. Can we try B1? The following shows that all the liquids from a test tube is poured into a beaker. Okay, so it is liquid. We are talking about which of the following about the liquid in the test tube and the liquid in the beaker is true. They have different volumes. No, they have the same volume. They don't have the same. They have different. They have same volume. So this is incorrect. They have different shape. This is true. Okay. They have the same shape. This is not correct. They have the same volume. True, true, but different shapes. True. So answer is C, right? They take on the shape of the container. Okay, then B2, which of the following about solid, liquid, and gases are correct? So let's look at option A. Particles vibrate about their fixed position. True. Liquids move about freely and randomly. Not true. This is for gas. So this is true. This is correct. So A is not correct. Okay, solids cannot be compressed. Can be compressed. That's wrong. Gases can be compressed. Yes. Solid does not flow. True. Liquid flow. Gases does not flow. This is not true. Now, solid exists below the melting point of the substance. True. Above melting point and exists above boiling point. Okay. So actually, to be more precise, we should say it exists above melting point and below boiling point. Okay, because if I just say that it's above the melting point, then what if it goes above the boiling point? Then it wouldn't be a liquid anymore. So the answer here will be D. Okay. So actually, liquid and gases, right? They are collectively known as fluids. Okay, we definitely know that liquids is fluid, but gases, because they can flow, so they are also classified under fluids. All right, so this will be covered when we are doing thermal processes. Okay, let's do success criteria C. Infer from a Brownian motion experiment. Okay, this is by a physicist called Mr. Brown. Okay, so from this Brownian motion experiment, he had the evidence of random motion of molecules in a liquid or gas. Okay, so take note, liquid or gas, they are actually fluids. Okay, and they can flow. Okay, so he actually did this experiment whereby he put some flower pollens in in water, and he sees from a microscope that the flower pollens are constantly moving. So he's wondering, because the flower pollens are not alive, so how can they be moving about in the water? So he proposed that actually it is the liquid particles that are in constant random motion, and they are constantly colliding with the flower pollens, and they create a resultant force that causes the flower pollen to move about. Okay. So what is Brownian motion? It refers to the continuous random motion of tiny particles, such as pollen and dust specks, suspended in fluids. Now you can actually see the tiny particles. So he uses pollen and also some dust specks. And when they are suspended in fluids, these are the things that are invisible. Okay, but it actually shows us that particles are in continuous random motion. Okay, so this explains that the random motion of tiny visible particles is due to the invisible fluid particles moving about randomly and bombarding the suspended particles from different directions. Okay, so maybe this is a flower pollen. So at any one time, maybe there are three maybe air particles colliding it from the left, and there's a one air particle colliding, hitting it from the right. So the resultant will be 2. Okay, he will move to the right, but after that it may change. The number of particles that collide with it will be different, the numbers will change, and also the directions will be changed. Therefore this haphazard, okay, this random motion is it is Brownian motion. So how can we study Brownian motion? So sometimes O level will ask us to draw the setup. Okay, so don't have to be too elaborate. Firstly, we need a lamp so that we can shine the light on the particles that are inside the fluid. So in this case, we use an air cell. So inside there is air, and also all these little dots here are actually the smoke particles. And because the smoke particles may be really small, okay, not easily seen, so we use a microscope. So with the light shining on the smoke particles, they will reflect the light, and we can see these light sources actually darting about in random directions and random speed. Okay, so sometimes they will ask you to draw the path of this Brownian motion, or this particle that is exhibiting Brownian motion. Okay, so take note to draw with straight lines and to draw arrows to show the direction. Make sure the arrows follow the path. You cannot be drawing things like this. You cannot draw things like this. So obviously this direction is incorrect. Okay, so just be careful, but draw with straight line. Okay, note number 1, the smoke particles exhibit erratic changes in direction of motion, right? Because at any point in time, there is a different number of air particles knocking into it in different directions. And Brownian motion does not occur in solid because the solid particles cannot move freely, right? Okay, let's try C1. The following shows some smoke particles trapped inside a transparent box. Their motions were observed to be moving erratically, okay, randomly using a microscope. So we shine a light, then we have all these smoke particles. They are moving in random directions. So the random motion of the smoke particles is called Brownian motion. What causes the Brownian motion is the collision between air particles. That is not correct, because if air particles they collide, I wouldn't be able to see anything. And now the focus is on the smoke particles. What causes them to move about in such a manner? The collision between smoke particles, that is not correct. It is the collision between smoke particles and air particles, and this is the answer. Okay, the air particles are actually colliding with the smoke particles. Okay, the energy from the light to the smoke particles, that is not correct. Okay, so this is success criteria A to C.